Okay, welcome everybody. Thanks a lot for the introduction. So first of all, I would like to thank the team that contributed to this work. So I have the privilege to present here, but most of the work has done by the team. So the Swiss TPH team has done the dose calculation, and the team from the Imperial College have collected all this data in their cohort, and Public Health England contributed to the measurements that I will present. So SCAMP stands for Study of Cognition, Adolescents and Mobile Phones, and it's a prospective study with quite a large sample size, with about 6,600 people recruited from Greater London, and obviously we want to look into cognitive and behavioral outcomes, and one main aim is also to differentiate between the usage and the exposure, the physical exposure from radio frequency electromagnetic fields. If you want to see the details, there's a study protocol paper that is published, and there are already several papers. For instance, for a subpopulation, we also have operator data, so we looked how well is operator-recorded mobile phone use correlated with self-reported, with the common experience that this is not very well correlated. Then we also looked into the use in cross-sectional analysis on BMI together with media use, sleep, and also the social media use and behavior and mental health. Obviously, it's always difficult then when you do this cross-sectional analysis, whether there's really causality and whether it's use or EMF. So we need here better exposure assessment and dose estimates to look into the physical effects. So the aim of that presentation is to calculate this RF-EMF dose. We used a model that has been developed in the GERONIMO project. There are two publications also on the model for the details, Van Weel and Liorni, and Miles has also contributed a lot to this development of factors, and Wout, the Wout team is also involved in all these parameters that are used for the models. Basically, there are three types of input data. There's personal information, so just the body metrics that determine how much EMF is absorbed. Then there are scenarios that can be calculated. In principle, the model allows to calculate 28 different scenarios. For that study, we used 12 different scenarios, like mobile phone use, tablet use, in different position, whether you have it close to the head or like that, and also in which network you are, whether you're in a 2G or 3G network or in a Wi-Fi network. Then a further contribution is the far-field measurements that has been estimated for the whole cohort based on personal measurements in a sample of almost 200 children, which were conducted between 2015 and 2018. So this is the sample. You see at the baseline, which took place between 2014 and 2016, the median age was about 12 years, and then the follow-up took place 2 years later, so at the age of 14. Basically, almost equal distribution of sex and SCS, and quite mixed in terms of ethnicity. The information for the dose modeling came from different sources, and we had complete information from 3,200 people, and for the others we had sometimes to substitute from different questionnaires. So basically there was a baseline school assessment which was filled in by all the children, and that is very complete, and then the same at follow-up. Then there was a sub-study which was called the SCAMP biozone, where they went home, so they collected further data, and there was the parental online questionnaire, which also had a bit more missing because not all the parents filled that in. This is the relevant data for the usage scenario. So in 2000, or at baseline, about 70% had a smartphone, 10% still had a bar phone, and 16% had no phone at all. When they grew older and technology developed over 2 years, obviously this picture has changed. So then 90% have a smartphone, almost no bar phone, and surprisingly still a few didn't have a phone with 14 years of age. The duration is a few minutes per day for calling. It's interesting, the duration of Wi-Fi internet use also increased a lot in this age category, from 20 minutes to more than 1.5 hours. On the other hand, for instance, tablet use, probably that is the tablet from the parents, this has reduced rather when they became older. This is the input from the personal measurements, exposure of far fields. So this is collected for the total radio frequency, and the downlink is from mobile phone base stations, uplink from mobile phones, Wi-Fi broadcast. So the median in that collective was about 100 microwatt per meter squared. You see the median is always this black line here, and then you see the variability. There's a lot of variability. Typically, exposure is relatively low at home and highest during travel. And the main contributor is downlink. Uplink is also relevant, and the Wi-Fi and broadcast there contributes a bit. There was one participant who had very high broadcast exposure, and cordless phones from DECT almost do not contribute. Just as a comparison, when we do the same type of studies in GERONIMO, which were 5 different cohorts and a sample also from Slovenia, that the median was a bit lower, 76 microwatt per meter squared, which may on the one hand reflect that GERONIMO measurements were done a bit earlier and maybe less urban region. And this is then the calculation of the dose at baseline, the same type of graphs. This is the median, the diamond is the arithmetic mean, and you see for these different tissues, also here the value that you can see. So basically, let's start with whole body. The median value is, or the mean is 170 and the median is 111 for millijoule per kilogram per day. Lowest dose is obviously for the heart because it's closest away from when using a mobile phone. Otherwise, it's very relatively similar value. We have calculated separate dose for the left and the right hemisphere, and because there are more right side users, that the right side is higher, the temporal lobe, which is then the highest exposed tissue. If we now move to follow-up, you will not see a lot of difference. So this is follow-up, this is baseline. So you see it's almost the same, it didn't change a lot. Let's look into the distribution. On the left side, there's the absolute distribution for the different tissues, and here the relative contributions. It's very green, so basically the mobile phone network calls on 2G are the main contributors in absolute terms and also in relative terms for most tissue. For the heart, it's a bit different. Generally, the dose is very low, and the contributions then comes more from scenarios where you have the phone close to the belly or the heart. And also for the whole body, then these other uses contribute more, and the calls are only a smaller part of the contributions. Again, quite similar results if you go to follow-up, does not change a lot on average. So then let's look how does this dose calculation correlates between baseline and follow-up within the same subject. And these are the correlation plots for different tissues. And you can see the R squared is quite low. This translates to a correlation of about 0.25 to 0.35. So this really means that in that age period of uptake of mobile phone, there's a lot of dynamic. So maybe if you get a new smartphone, your dose will change completely. If you break up with your love, then it may also have an effect on the exposure and things like that. So that's an important point, I think, also for us epidemiologists. You cannot rely that you do it once and then this is a very stable measure over time. But you really need to reassess those and use quite regularly in this age group, probably also in older age group, but in this age group for sure. Maybe these values are not well known, so let's compare a bit with other studies. These are the GERONIMO graphs, where similar calculations have been done on the left side for child cohort, so these are 2 Dutch cohort and the Spanish cohort, and here for the adolescents cohort, the Swiss Hermes and also a Spanish cohort. So if we plot now the SCAMP estimates to this thing, and this is now the median dose, so it's about 170 for whole brain and 110 for whole body, so it's a bit higher than observed in the children in GERONIMO, and also higher than what is observed for whole body. And I think this also has to do with the fact that smartphone use and data transmission has become more common in the SCAMP study compared to GERONIMO, where the data is quite older, but which has been collected between 2012 and 2016. Hermes is here very high because the self-reported estimate, this is based on self-reports, and we have some evidence that this is overestimated. Operator-recorded mobile phone use would be lower. Also, the left and right temporal lobes are quite in line with what has been observed in the INMA cohort. And probably if you would do the same calculation in Hermes with the operator-recorded phones, it would also be around here. And here a comparison with the adults. So this is also based on the GERONIMO model, but here the usage data from surveys have been taken from 4 years, and that is what has been observed in adults. In principle, a similar pattern that most of the exposure is for own device use, that mobile phone base station only contribute little, and for brain dose anyway, it's very little. If you look at the absolute value, it's a bit higher than what has been seen for children. I mean, the model is the same, but there are some differences in how it was calculated, how the scenarios were selected, what was the default. For instance, in the GERONIMO, it was assumed that 50% of the calls were 2G and 50% 3G. And 4G, for SHOP 4G, it was the same assumption as 3G. In SCAMP, because it was later, we assumed that only a third of the calls is 2G and 2/3 is either 3G and 4G. And for 4G, there's no proper dose estimates in the GERONIMO model, but we use just the 3G model. Okay, let's summarize. Basically, the brain dose increased a bit, the whole body dose remained relatively constant on average within that study collective, despite more use. The correlation of individual values was quite modest, so that is certainly a challenge for epidemiological exposure assessment and should be considered in future studies. And the SCAMP dose is quite in the middle between the children studies and the adult studies, so that makes some sense from usage point of view. I didn't talk too much about the dose model and the assumption behind, but basically it's a linear no threshold assumption, so you just add up everything like for ionizing radiation. Obviously, there's no known mechanism for non-ionizing radiation which fulfills that. For instance, for thermic effect, we have a threshold. But on the other hand, I think it's a very conservative approach of also giving some weights to low-level exposure where people are concerned. But I think in the future it would be useful also to try other metrics like certain threshold that you would like to calculate and then see how the dose distribution looks and whether this is related to any kind of outcomes then in the cohorts. And then really, I mean, dose modeling is a large uncertainty, and we have not even quantified it so far, but one of the main uncertainties is the self-reported mobile phone use, where we have evidence that there's a high variability. Then you have to make some assumption about the distance, which may be on average quite okay, but for an individual, whether you have it here or here makes quite a lot of difference. And then the output power of the devices can be orders of magnitude different. So again, on average, this might be quite okay, but for individual dose estimates, it introduces a lot of uncertainty. So the message here is, I think these figures are very useful to say what is the typical exposure of the population of that sample and things like that. But for epidemiological research, we must really improve. I mean, I don't really trust that you can do too much with that type of things. And it's better than just asking about mobile phone use. So it's a step forward, but we really need to go further and have more reliable and objective data for exposure assessment. So that is my key conclusions, and hopefully I took too much time, and happy to answer any question.